Yay! Chapter 4! Starting to do some parabola work. So first, we're talking about quadratic functions. What makes it a quadratic function is that it has an x squared in the problem. Now when I graph this, it creates a graph that's called a parabola. And the shape of the parabola is a U, like this. Not a V, a U. So we cannot graph it the same way that we did our absolute values. But in this parabola, this is the equation that looks like vertex 4 would highlight that. This is the equation that looks like standard form. We can write them both ways. This one's easier to graph from. In every graph, not every graph, in this graph and just like absolute value, you have an axis of symmetry, the imaginary line that would cut this in half and make it the exact same on both sides. In this graph, you have a vertex of the parabola. Same thing as absolute value. This one's always opposite, and this is as is. And that's where the graph starts, and then from that point, it either goes up or it goes down. Let's start some fun stuff. So first, just looking at the parent function. So if I look at my parent function, there's no numbers here moving left or right or up or down. So my vertex here would be 0, 0. So here, I'm going to evaluate 0, 0. So unlike the absolute value, we could just graph it by the a. We can't do that for this. We're going to actually have to find a table. So if I plug -1 into my equation right here, I would get a +1 out, because -1 squared is +1. -2 squared is +4. 1 squared is 1. 2 squared is 4. See how it's not going up by the same amount each time? That's because it's getting larger. It's exponential. So if I graph this, 0, 0, and on the left and the right, go up by 1, and then I have -2, 4, +2, 4. You should always have at least 5 points, and you should have a smooth curve. It should look like a U. Mine's not the best, but that's what it is. When I'm looking at my domain, I always think, how far left does this graph go? Well, if I look on the left-hand side, it's going up, and it's going up forever. And I look how far right does this graph go? And it's going up, and it's going up forever. So this would be all real numbers. All real numbers. We can put any number in for x. There's no restrictions whatsoever. If I look at my y value, it's how far down does it go? Well, this is the furthest down, and that value there for y is the same value of my vertex. So I'm going to write y, and then a space, the 0. Now I have to think, is the graph going above that point, or is it going below that point? Well, the graph is going above, so that means 0 is my smallest point, so y is getting larger, but it also is equal to 0. So my range would be y is greater than or equal to 0, because those are the numbers that the y output could be. So I want you to graph this one and try the domain and range by yourself. So with parabolas also we have the reflect, stretch, and compress. So when we reflect, that means it flips over the x-axis. If we're stretching, that means that a value right on front, the same location in the absolute value, is getting or is larger, so that means it stretches out, it gets skinny. Or compress, if the a value is in between 0 and 1. Remember, the negative is what flips it. So if I graph this, I look, the a is not there, but on the outside of the equation, the parent function, it's a -5. So I have a down 5. So that's going to change my vertex. My vertex here did not move left or right, but I moved down 5. So I can create a table for that. If I plug 0 in, and then I would want to check -1 and -2, 1 and 2. So do that. And if you plot your points there, it would look like this. So now I look at my domain and range. How far left do I go? Well, that arrow goes on forever. How far right do I go? It goes on forever. So my domain will be, all real numbers. Again, like this. I did it wrong. But my range, how far down will I go? Well, the y, the very furthest down it will go is this spot right here, and that's at -5. My graph is going above that, but so it would be y is greater than or equal. So now if I move on to B is in boy, my transformation here would be to the right 4. Because remember, on the inside of the equation, it's always opposite. So if I do my table, this would be 4, and I do not move up or down at all. So I want to do 3, 2, and 5, 6. So fill in that table and plot those points. So 2, 4, 3, 1. Oops, I didn't follow the dots very well. 4, 0, 5, 1, and 6, 4. So when I look at my domain, still going to be all real numbers. My range, the furthest down I go, right here, is 0. My y value, range is y, and it's getting larger, so y is greater than or equal to 0. So I want you to try C and D by yourself. So problem 3, I'm looking for my vertex. Remember, vertex is going to be if you, whoopsie daisy. Vertex is going to be if you move to left or right, so in this case I move right 4, and I move down 2. When I find my axis of symmetry, that dotted line is always the x value, so it'd be x is equal to 4, because it's always dependent on where your vertex starts. My minimum and maximum, this is where you want to look at your a value. Sometimes I tell people, draw a little sketch of what you think this might look like. Basically, it's not flipping, so it would look something like this. Now, if it looks something like this, that means this is going to be the lowest point, so it's going to be a minimum. And that minimum point will be my y value. So y would be equal to -2 for my minimum point. It's not going to get any lower than that. And then I have my domain. Now if I look from the left to the right of this little sketch, I can go either way. So it's going to be all real numbers because it's going on forever. If I look at my range, the lowest point that will ever go will be at that -2. It's your minimum. That means the graph is getting larger. So I want you to try to do the other one by yourself. Remember, when you draw this sketch, it's going to be a flip because of this -2 right there. And finally, what if I'm graphing with some other numbers out in front? So I'm still going to find my vertex. My vertex here, when I'm looking at this, did I move left or right? Right here, I'm moving right 1, and I'm moving up 3. So that's going to go in my middle, right 1, and up 3. So I'm going to evaluate 2 and 3 and 0 and -1. And I can do that mental math, or else you can really do it in your calculator if you so wish to. So if I were to graph this, I have 3, -5, 2, 1, 1, 3, 0, 1, -1, -5. It'll look something like this. Now, again, it should look skinnier because the 2 out in front stretched it out, so it looks skinnier, and the negative out in front flipped it around. So my domain, when I'm looking at this, how far left, how far right, still have that arrow. It's going on forever, so it's still going to be all real numbers. Now when I'm looking at my range, right here at this point, my vertex, my range here is 3. That's what the point on the vertex. But now it's going below that. So y is everything below that. So y would be less than or equal to 3. So I want you to do B by yourself, and then I want you to have a great, grand, wonderful day.